Okay, on page 36 in the lab pack, the bottom half of the sheet describes the hormones that affect blood pressure. Primarily the ones I'm going to talk about today, all will save you from dying, hopefully, or just a temporary decrease in low blood pressure. So that basically it can up your blood pressure and you can stay alive, keep the lumens of the blood vessels open so that they do not collapse. Once a blood vessel collapses, they cannot just magically reopen. And so it will be like creating a dam effect. If a lumen closes, then all the blood behind it is going to pile up against it. And eventually that will increase the size of the artery or the vein wherever this happens. And then eventually it'll rupture, an aneurysm will occur, and that's a bad deal. Right. So anyway, I have all the hormones listed in this table or the chart. And then I'm going to have a drawing that explains this because there is an order in which you release these hormones based on the glomerular filtration rate. And so anyway, first of all, I want to show you again, basically, here is my nephron right here. Okay, here's Bowman's capsule. And now there's a couple other structures that are important in this whole story of maintaining blood pressure and secreting hormones. And so anyway, the first structure, there's going to be some loose T cells that are in the stroma of the organ right here. And we have these, they're in between the Bowman's capsule and the DCT over here. And so I have them on both of my nephrons here as this little spongy thing right here. Those are called the JGA cells, glomerular apparatus cells, juxtaglomerular apparatus cells, and they're in between the Bowman's capsule and the DCT. So they're loose T cells, and they're going to, if they do not feel pressure from the Bowman's capsule against them, if the Bowman's capsule is not creating pressure on them, then basically they know that the glomerulus is not dripping fast enough to fill up this funnel. And so it will actually pull away. The Bowman's capsule pulls away from the JGA, and then they say, oh my gosh, the glomerulus is not basically dripping fast enough, and so it's pulling away, it's shrinking away, and so immediately the JGA cells are going to be the first ones to respond, to make some hormones to help hopefully increase the glomerular filtration rate, a faster drip rate, to fill this up so that you can reabsorb water back into your vasa recta and basically up your blood pressure to keep those lumens open. So these are the JGA cells. Now there are some other cells that are right next to, they're in the DCT wall. And so this DCT tube has cells that are right next to the JGA cells. They're simple QBT cells. They're part of the wall of the tube, and they're called the macula densa cells. And the macula densa cells make the hormones that also help save you from low blood pressure, right? And so we're going to talk about these in the diagram on the board, but this is the concept. So basically, when you have normal blood pressure or even high blood pressure, you're going to have a fast drip rate, and these cells, the JGA cells, are going to feel the pressure, and so they don't have to make their hormones. No hormones are required if you have normal blood pressure. And so if you have high blood pressure, some other hormones are required, and so we'll talk about those here in a minute, okay? So that's the concept. All right, now, once I put it on the board so you can understand this, here is my nephron. It's not a fancy one. So here's Bowman's capsule. Here's the glomerulus that will drip in to the space. Okay, great. Here's my PCT, the loop, the DCT, and now the distal convoluted tubule, you have to look at the nucleus, because on this side, right here, they have a target nucleus, like in the stomach, okay, for the APUD cells, the ones that produce the hormones. And so right here, these are going to be the macula densa cells. And so macula densa cells have a target nucleus. They're simple QBTs on this side only. On this side, these are normal, just normal simple QBT cells with like a chocolate chip nucleus. And so they do not have the target pattern that indicates hormone production. All right? And in between Bowman's capsule and the distal convoluted tubule, the MD cells, here are all the pink, basically JGA cells, the Lucy T cells sitting in between the DCT and the Bowman's capsule, so they can feel the pressure of the drip rate as it fills up the Bowman's space. All right, and then the rest, AT and the ST, straight tube. All right, so now basically we got to talk about the hormones that are going to be released if you have low blood pressure. So that means you are not going to have a good drip rate from into here, and it's not going to fill up your capsule, and so this capsule is going to move away. It shrinks back, and now the Lucy T cells are going to spring into action. So basically the JGA cells, the first hormone it's going to make is something called EPO. And so EPO is made in these cells right here, okay? And it's released into your bloodstream, secreted into your bloodstream, and it's going to take a ride. And so it's going to take a ride to every bone marrow cavity in the human body. So this is called EPO, okay? EPO hormone is going to be released first. And so all hormones, and we'll talk about this when we get to the endocrine system, they all work on feedback loops, okay? Positive and negative feedback loops. So negative feedback loops means that when one decreases, okay, as it decreases its level, then it will turn on another hormone. And then a positive feedback loop means that when one increases, it'll turn on another one. And so basically EPO is basically from this pressure, not feeling pressure, it's going to be released, and it goes to every bone marrow cavity. What does EPO stand for? It stands for erythropoietin. Erythropoietin. And if you notice, erythro stands for basically erythrocytes, red blood cells. Has something to do with red blood cells, and so RBCs, right? All right, so what's going to happen is immediately, if this is not feeling pressure, the EPO is released and it's going to go into the bone marrow, okay? And it tells the bone marrow, it's going to come in here in the bone marrow, the EPO, and it's going to tell it to release immediately more red blood cells. And that's what it does. And so immediately, red blood cells are going to start getting loaded, lots of them, in your capillaries, and they go out in circulation, lots of them, really fast. And what does it carry? Oxygen. And so all these red blood cells, okay, are loaded with oxygen. And so what is that going to do for your blood pressure? Well, when you release all these red blood cells with oxygen, it's like releasing thousands of mini balloons, and it's going to open up the lumen with the oxygen. It's a physical presence. And so it actually physically, with the oxygen being carried on the cell membranes of the red blood cells, it's actually going to balloon open the lumens, and that's going to make your blood go faster and keep the lumens open with the increase of oxygen. And so EPO is what Lance Armstrong misused in all of his races, and I always call EPO the Lance Armstrong hormone, named after him, because he used that during his races to release more red blood cells so that he could get to the finish line first, which obviously it worked because he had more oxygen available than the rest of them on those Grand Prix racing circuits. So anyway, so that's the first hormone. Now, if that doesn't increase your blood pressure and make the glomerulus drip faster, open up the lumens, and save you from dying, basically there's another hormone that's going to be released by the JGA cells, okay? And so the second one I'm going to make is pink. And so here's my pink one, pink hormone. And this would be the second one that gets released if this doesn't the GFR doesn't increase with this first one. And so it's working on a feedback loop. And so if it doesn't work, then basically, then this one's gonna happen, and it's gonna go to the adrenal glands. And so this hormone is pronounced renin. Renin. There are so many people that pronounce it renin. I've heard renin more than I've ever heard renin. So anyway, renin. And so renin, this hormone is made by the JGA cells, and it's going to go to the adrenal glands and stimulate the simple QBT cells to make their hormones, okay? Their hormone. And so what hormone are they going to release? Well, they're going to release aldosterone. So I'm going to make this hormone as green circles. Green circles. And so here's the hormone they're going to release. And so it's called ALD. And so here it goes. And I'm going to make a green line right there. So this is ALD, aldosterone, okay? Aldosterone. And it's a pretty potent hormone. And so it takes a ride and it gets inside the wall of the blood vessels. And basically it's going to go to the tunica muscularis. And so this hormone is specific right here, and it goes to the tunica muscularis. And what does it do? Basically, it tells the tunica muscularis cells to make and release basically angiotensin 2. Angiotensin 2. And so the tunica muscularis is going to make angiotensin 2, which is a vasoconstrictor. Vasoconstrictor. Right here. And so basically it makes that vasoconstrictor, and the afferent arteriole is going to clamp down, and it's going to push more blood into the glomerulus, which will make it drip faster. And so that's a cool idea. And so anyway, it vasoconstricts angiotensin 2 on the afferent arteriole specifically. And when this contracts, then basically more blood's going to be pooled in here in this glomerulus, and it will drip faster. And then you'll have a faster rate of absorption and reabsorption and secretion, and that should open up your lumens of your blood vessels and save you from dying of low blood pressure. So that's the second hormone that gets released from the JGA cells, okay? And so that would be number 2 step. So if EPO doesn't do it, then they're going to release renin, which would then release the aldosterone, and hopefully that will save you. All right? So aldosterone is made exclusively in the adrenal glands. All right, now the next hormone. If these two don't work, then the macula densa cells. If the macula densa cells do not feel pressure from these hormones, physical pressure against these cells, because if they don't feel pressure, then they know they need to make their hormone. And so basically their hormone is going to be renin, okay? It's going to be some more renin. And so the renin is going to be, we'll make it light blue, okay? Light blue. And so I'll put light blue in here. And so this hormone is exactly the same as what the JGA cells make. And so the MD cells, the macula densa cells, the simple QBT cells of the DCT are going to release it into the blood, and it's going to come over here and tell the adrenal gland make more aldosterone. We need even more throughout the entire body to help constrict and move the blood faster in the entire body. And so basically, this is going to be the third hormone, okay? Number 3 hormone, and it's renin right here, but it's from the MD cells. The MD cells, okay, the MD cells. and it goes in here and it tells it to make the aldosterone. Right, exact same thing from the JGA cells, all right? So renal, the pinky ones from the JGAs, right? JGA cells, Lucy T cells. All right, so that's the next one, all right? So now, if that doesn't work really well to save you from low blood pressure, and you could have an accident, you could be bleeding out, and all of these are kicking in, but they all have to go in a pecking order. They all have feedback loops, and so you don't make all of these and dump them immediately, right? And so now the last thing that will happen is something called ADH hormone. And so this is going to be our, fourth one? And so it's going to be made, this fourth hormone right here. ADH, it's made in the pituitary gland. It's also made in the hypothalamus. And, but basically it's released, and it is also made in the pituitary gland. ADH is anti-diuretic hormone, and anti means against, and diuretic means water, against water loss. And so in the medical world, it's called vasopressin. And this is when people, their blood pressure is dropping. This is like liquid gold, this medicine in the hospitals. It will save you from death. Not all the time, but most of the time. And so vasopressin, it's a very expensive drug. It's a controlled substance. And nurses actually have to sign out to actually inject that and use this drug. So anyway, so what does ADH do? ADH gets into the blood, all right, and it's going to go into the kidney. And so when the kidney comes in when the blood comes into the kidney, the capillaries are going to leak out this hormone, and this hormone is going to go to the straight tube cells, it goes to the DCT cells, and it goes to the loop of Henle cells. And so ADH goes to all three, okay, all three. And what does it tell it to do? It tells it to save water. Save water. Do not release water in your urine. You want to save it and put the water back in the vasorecta. So in all three areas right here, it's going to basically save water and put back into the VR, vasorecta. So you'll have less water going out in your urine. Your urine will be more hypertonic, and so basically it'll be much less water when ADH is present. So also on ADH, in my little chart right here, ADH, it tells it to reabsorb the water, but also in the distal convoluted tubule and the loop of Henle, you'll also be able to absorb some salt with it, right? So when you reabsorb salt, it also helps pull more water out of the cells even, and out of the lumen. And so basically here and here, right here in the loop, right here, and in the DCT right here, it can also absorb more salt, NaCl, with the water, So straight tube, nothing to do with salt, water only. So basically it's going to do water only in the straight, and then the sodium chloride in the D and the loop of Henle right there. And so that's our last and very powerful hormone to help with low blood pressure. So those are the main hormones right there. Also, there are other hormones made elsewhere, like angiotensin 1 and 2, which vasodilates and opens up your blood vessels to lower your blood pressure, and angiotensin 2 is also made in the liver, which constricts. They can also contribute to help this, but the initial angiotensin 2 that's made comes from the adrenal gland stimulation, the aldosterone stimulates the muscle cells to make angiotensin II, right? So for vasoconstriction. So anyway, different tissues can make angiotensin 1 and 2, like the liver, that's simple QBT cells that make it, but aldosterone is not. Aldosterone comes from simple QBT, but then it stimulates the smooth muscle to make the angiotensin II. So anyway, there you go. So these are the hormones that are exclusive to the kidney, involved in the kidney regulation of blood pressure, and there you go.